Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on power of 2. This problem looks very simple, but it is perfect to understand the base cases and recursive calls and how recursion breaks a problem into smaller subproblems. So we are given an integer n and we need to return true if it is a power of 2. Otherwise, we need to return false. So a number is a power of 2 when n equals to 2 power. Okay, here if you see n equals to 2 power x, where x should be greater than or equals to 0. Now we need to think recursively, but before coding, let's ask this question. How does a power of 2 behave? If n is a power of 2, then it is divisible by 2, and repeatedly dividing it by 2 should eventually reach 1. So the base cases would be if n is 1, then it is a power of 2. If n is less than or equals to 0 or n is odd, then it is not a power of 2. If n is even, then the code would be we'll be calculating n by 2 in the next iterations. It would be easy if we write the code. So the base condition is if n is 1, then we will return true. Okay. When should we return false? If n is less than or equals to 0, or if n is odd. We can say it as if n mod 2 is not equals to 0 or n mod 2 is 1, also comes under odd, then it is then we will return false, because that is not that number is not divisible by 2, so it is not a power of 2. Otherwise we will return is power of 2 and we'll pass n by 2 next time. This is the recursive call. Now if we dry run, it will be easy for you to understand, but before that let's run the code. Okay, it is accepted. Let's submit it. Okay, it is working. So for any recursion problem, it is very important how you dry run the code. For example, let's say if n is 16. Okay, if n is 16, then first we will call this method passing 16. So first we will call 16, then it will check if n is 1. No, n is 16. If n is less than or equals to 0, or n is odd. No. So we will return this, we will call this method is power of 2, but this time we will pass 8, 16 by 2. Again it will check, is it 1? No. Is it less than 0? Is 8 equals to 1? No. Is 8 less than or equals to 0, or 8 is odd? No. So again we will call this method now by passing 8 by 2, which is 4. Again it will check if 4 is equals to 1. No. If 4 is less than 0 or 4 is negative. No. So now we will return 2 of 2. Again, is it 1? No. Is it less than 0 or odd? No. So now we will call 2 by 2, which is 1. Now is it 1? Yes. So we will return true. So that's how for 16 we got true. So yeah, this is a very easy problem just to understand the recursive calls. And the time complexity for this would be O of log n, and the space complexity would also be O of log n because of the recursive calls. So the key takeaways here are: the recursion works best when the problem size reduces at every call, like how we reduced 16 to 8 to 4, 2 and 1. And when the base cases are crystal clear, then recursion is the best option, because we are sure that if n is 1, since we are dividing the given number by 2 again and again, at the end, if it is an even number, we will get 1. So if n is 1, then it is an even. So this base condition is clear, so that's why we can use recursion here. And we should always think, what is the smallest version of this problem? So the smallest version is, if n is 1, then we will return true. And one more question is, why the time complexity is O of log n? Let me write it here. Time complexity is O of log n, and space complexity is also O of log n. Okay, now, so let's talk in the context of power of 2 using recursion. So what actually happens here is, every recursive call does one thing. What does it do? It just divides the number by 2. So the sequence of the values look like, initially the number is 1, then this turns to n by 2, then this turns to n by 4, then this turns to n by 8, and this turns to n by 16, and so on. At the end it will become 1. So how many times can you divide n by 2 until it becomes 1? Is nothing but log n times base 2. Log n to the base 2 times. This is nothing but log n base 2. So that is the reason our time complexity is log n. Okay. Yeah. So yeah, since we divide the number by 2 in every recursive call, the number of calls grows logarithmically. Hence the time complexity becomes O of log n. So that is it for today's problem, and I'll see you in the next one.